Hi everyone, I'm just going to present a slightly different problem to you. This time I'm going to give you a non-right angled triangle, but this time with three known sides. And I'm going to ask you now to find the angle theta. So just thinking about this carefully, if you knew the angle theta but didn't know the opposite side to theta, so in other words, let's say theta was known. Okay, so you had a value there, and we'll just get rid of that theta for a moment. So let's say for argument's sake you had 70 degrees. You could then find the side x, okay, because you have two sides or two known sides and an included angle, and you know that that's the cosine rule, okay? So, or the cosine rule for sides. Let's say I reverse the problem, okay? So the problem is switched. This time round, I'm going to give you the side. Okay, let's call it, say, 4 units. But I'm now going to ask you to find the angle. What do we do? So this looks very, very much like the cosine rule, but instead of solving for the a squared, so I might just write the cosine rule here. So a squared is equal to b squared plus c squared minus 2bc times cos of a. Okay, the dot here just means multiplication. So instead of solving for little a or the side a, we're going to solve now for the angle a. Okay, so the angle a is where I'm going to put that where the theta is. So all we're going to do is we're just going to rearrange the cosine rule to make cos of a the subject. Well, actually, in fact, a the subject. We have to use inverse cos, obviously, in this during this procedure. So let's start off by rearranging the formula. Okay. Now, in the textbook, or actually in a lot of texts, you're basically presented with the formula for the cosine rule for an unknown angle. However, I'm going to break ranks a little bit here and say, rather than remembering two formulas or trying to sort of, I guess, contend with two formulas, it's really the same formula. It's just a rearranged version of it. We know how to do algebra, we know how to work with equations, so why don't we use that skill? Okay, that's why we learn that skill, so that it removes or at least reduces the need to have to remember so many formulas, because a lot of formulas are actually related to each other. So let's move the b squared and the c squared over. So a squared minus b squared minus c squared is equal to negative 2bc times cos of a. Okay. Now we're going to divide both sides by negative 2bc. Okay, so a squared minus b squared minus c squared over negative 2bc is equal to cos of a. Therefore, a, which is the angle that we want, is going to be the inverse cos. Now I'm going to use square brackets here because they're cool. Okay, and just looks a little bit different. I just needed to draw when they're larger brackets. Square brackets are just a little bit easier to draw, and it's just easier to see that it's a bracket there. Okay, so this is now the cosine rule for angles. It's just the cosine rule. I've just rearranged it. So why remember two formulas, right? Formula 1 and Formula 2, when I could just take note of the one formula and then rearrange it to suit the need. Okay. Now let's use this formula to see if we can find a value for theta. Okay, and unlike the sine rule, we don't need supplementary or sort of obtuse, acute, the two answers. It's only going to be the one answer. Okay, cosine's very nice that way. All right, you don't have to think about sort of the ambiguous case, if you recall that. Could it be acute? Could it be obtuse? Don't worry about any of that. Okay, so a is equal to inverse cos, and I'm just going to substitute in the values. The a is the important one. That's the one you've got to get right. So make sure you've labeled it correctly. Okay, the theta is capital A, the 4 is lowercase a. Okay, so I might just put that there in a different color. Okay, so that's the one that you must get right. Okay, so 4 squared. Now the b squared and the c squared, it doesn't really matter which order you do them in. They're both being subtracted anyway. All right, so 2 squared minus 3 squared over negative 2bc. So negative 2, okay, times 2 times 3. All right. Okay, at this point here, I would say, you know what? You know what you're doing. The last part now to get, I guess, the final mark for correct calculator entry. Okay, so this is why showing the working out is so important. I am convinced at this point that if you can get to this point here, honestly, what you enter into your calculator doesn't really matter all too much at this point. In fact, if you don't get to this point, the calculator's useless anyway. So that's why it's so important to show you working. All right, so I'm just going to see if I can adjust the lighting a little bit here so you can see what I'm going to enter in on the calculator. Okay, shift cos. Hopefully you can see that. Yeah, I can see it there on the screen. Inverse cos, shift cos, 4 squared minus 2 squared minus 3 squared over negative 2 times 3. All right. And we get 104 degrees. Now, so let's put in degrees in minutes. So we get 104 degrees and 29 minutes. So it's rounded. Okay, so it's roughly, that means roughly equal to 104 degrees and 29 minutes. And so there's another application of the cosine rule, except cosine rule for a missing angle or an unknown angle. So now we have two situations where we can use the cosine rule. Okay, I might just flip the board. Okay, around. Okay, we have two situations. We have situation, so this is situation 1. Okay, where we have, I'm just going to put dots there to indicate the known sides. Right. So you have two known sides, okay, and an included angle, or you have 3 known sides. Okay, and so they're the two situations that you would use the cosine rule. The sine rule, okay, as you know with the sine rule, okay, so I'm not writing it all on the board, so just listen in. The sine rule, you basically need a side angle pair, okay, and you also need something else. So either that or another side somewhere. Okay, so I'll just move that over a little bit so you can see it. Okay, or okay, you could have 2 angles. Okay, but you also need a known side somewhere as well. Okay, so any side will suffice, because once you have 2 angles, the third angle can be known anyway. So these are the two situations where you would use the sine rule. So it's really these side angle pairs that are so important. Okay, so there's another one here, right? So these are the side angle pairs. You need to take note of those and see if you can find those. So with the cosine rule, okay, cosine rule is 3 known sides or 2 sides and an included angle. Okay, thanks for watching everyone, and wishing you all the best for your studies.